today we're talking about graphing polynomial functions. So this is kind of, well, it's really a mashup of everything that we've done so far in this unit. And we're going to look at graphing some different types of polynomials. So before we have done just parabolas. Today we're going to look at what we get when we graph one that is x to the third power and x to the fourth power. All right, so let's get started. Our instructions say to find all the real zeros of a polynomial. Remember, we learned last lesson to find all of the real zeros, we have to first find a list of potential zeros, right? All right, so, and our formula for that was plus or minus p over q, where q was the coefficient, the leading coefficient, and p was the constant. And not just the constant or not just the leading coefficient, but all the factors of it. All right, so let's look. What goes into, let's list all the factors. What are the factors of 6? 6, we know we have 6 and 1, and we have 2 and 3, right? So 1, 2, 3, 6. And our leading coefficient here is 1. So our possible zeros are just going to be 1, 2, 3, and 6, because 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 3, you get the idea. All right, so first we need to set up our synthetic division, and we're just going to start with positive 1, right? So let's list all of our coefficients. So I have a 1, I have a negative 6, I have a negative 1, and I have a 6. Looking to make sure that we don't need to put in any placeholder zeros. So I have x to the third, x squared, x, and then a constant. So I'm good. All right, bring down my 1. So 1 times 1 is 1. Negative 6 plus 1 is negative 5. Negative 5 times 1 is negative 5. Negative 1 plus negative 5 is negative 6. Negative 6 times 1 is negative 6, and that is 0. Yay. So that works. So we need to set in our x's here. So remember, this is our remainder. This is our constant. That makes this our x term. That makes this our x squared term. All right, and then we can factor this. Our leading coefficient here is 1. So we can just use our shortcut direct factoring method. So I need to put an x here and x here. I need to know what two numbers multiply to make negative 6, but add to make negative 5. We've already listed all of our factors over here. So let's look. Remember, when we're multiplying to get a negative, we need a positive number and a negative number. So we're really looking for two numbers that the difference between them is 5. And look, 6 and 1. We want our bigger number to be negative, so I'm going to say negative 6 and positive 1. All right. So we know then that our zero, our first zero, is 1. And then I set each of these equal to 0. So x minus 6 equals 0. X plus 1 equals 0. Add 6 to both sides. So x equals 6 and x equals negative 1. So our answers here, our zeros are 1, 6, negative 1. All right, and then we want to graph this. So how do we graph this? All right, so our zeros are just like when we were graphing a quadratic equation. Remember way back when we were graphing our quadratics and we found the zeros? That's anywhere that x equals 0. So if we're graphing it where x equals 0, excuse me, yeah, no, where y equals 0, if I say this properly. What does x equal when y equals 0? So in this case, we know that x equals 1 when y equals 0. We could put a dot there. We know that x equals 6, 1, 2, 3, 4, 5, 6 when y equals 0. And we know that x equals negative 1 when y equals 0. All right, so now the question is how do we graph this? What does a x cubed graph look like? Any ideas? All right, well, let's pull up test notes here. All right, hopefully you'll be able to see that at this point. So we're going to put in our equation here. So it was y equals, we have to put that, x cubed minus 6x squared minus 6x squared minus x plus 6 minus x plus 6. All right, and I'm going to zoom out. All right, so you see, hang on, get a good. All right, so you see how it goes up and then down? So if we're going to go back over here, go back to our original page. So when we're graphing this, we're going to need to go up and then down. All right, now notice mine does not look exactly like the Desmos one. Desmos one was kind of squished and it was showing exact. In fact, this should be a little more rounded there. All right, I'm not looking for an exact representation. All right, if you can just show me that, hey, it basically goes up and down in between these zeros, then we're good. All right, so and the way we tell what this looks like, all right, how we know that this goes up and down and not down then up. All right, very important. And we tell by the same exact way that we tell for a parabola. Remember on our x squared ones, you know, x squared plus 6x plus 7. Remember, we knew that it opens up if our leading coefficient is positive, so it looks like this. Okay, same way on an x cubed one. This is positive over here. So our rightmost parabola part of it is going to open up. Okay, so let's practice on the next one. All right, so first thing we notice, looking here, this is positive. So we know that this one is going to be one like this, right? When we go to graph it here in a minute. So let's keep that in mind. Now we need to find our zeros. So same process we've been doing. You need to list, remember, plus or minus P over Q. I don't know why I keep trying to write G's instead of Q's. Okay, so all the possible factors of 40. So we know we have 1 and 40. We have 2 and 20. 3, no. We have 4 and 10 and 5 and 8. Does 6 go into it? No. Does 7 go into it? No. Okay, so this is where we are. All right, so let's start. Remember, our leading coefficient over here is 1. Our Q is 1, so we don't even have to divide these. We just know that it's plus or minus all of them. All right, now we can go through a big old long list of all of these until we find the first one, but I'm just going to tell you for this particular one, 4 is one of our zeros. So let's just use 4. So 1, negative 7, 2, 40. Double check to make sure we don't need any placeholders. I have x cubed, x squared, x, and a constant. So we're good. Bring down my 1. 1 times 4 is 4. Negative 7 plus 4 is negative 3. Negative 3 times 4 is negative 12. 2 plus negative 12 gives me negative 10. And negative 10 times 4 gives me negative 40. And this is 0. All right, so then let's set it up. That's my remainder. So this is my constant. This is my x term. This is my x squared term. My leading coefficient is 1, so I can factor this using the direct shortcut method. So I know I get an x here and an x here. And then I say what two numbers multiply to make negative 10, but add to get negative 3. So let's say factors of 10 here. So 10, I know I have 10 and 1 and 5 and 2. All right, this is a negative 10, so I need a positive and a negative number when I multiply, and I need the negative number to be bigger. So what two numbers have a difference of 3? Well, right here, 5 and 2. I need the negative number to be bigger so that when I add them, I end up with a negative 3. So I'm going to have a negative 5 and a positive 2. So now we can list our zeros. First off, I know that 4 is a 0. I need to set each of these pieces equal to 0 so I can find out what my other two zeros are. So this is going to be x equals 5 And this would be x equals negative 2. So my other two zeros are 5 and negative 2. Then I can plot my zeros on the graph. So x equals 4 and x equals 5 when y equals 0. X also equals negative 2 when y equals 0. Also a note to make sure you guys are double checking to make sure you have the correct number of zeros. Look back to your original function. This was a x cubed. Notice that exponent is a 3, so I should have 3 zeros. Look, 1, 2, 3. So we have the right number. All right, so now let's kind of construct a rough graph of this. Remember we said at the very beginning, we looked at the leading coefficient in front of the x cubed and it was positive. So we know our graph is going to look something like this. So we just need to kind of do a rough sketch of it. All right, I am not expecting this to be exact, guys. All right, give me a rough idea that says, hey, I know the basic shape that it should be. I'm not expecting you to plug numbers in and find out exactly where my y-intercept is. No. All right, just give me a rough idea. All right. Next we have 2x to the fourth. And not just 2x to the fourth, but a negative 2x to the fourth. All right, so do you remember what did a parabola look like when it had a negative coefficient? It was upside down. All right. Similarly, a x to the fourth one is going to look very similar to this. All right. So an x to the fourth. So let's back up. So the x cubed ones, you saw that looked kind of like two parabolas joined at the hip here, right? One seamlessly flowing into the other. All right, an x to the fourth graph looks kind of like that, except it looks like two full-on parabolas joined by a parabola in the center. Okay, we're just adding an extra parabola every time. Does this make sense? Not really, but as we practice it, you'll get it. All right, this is a regular quadratic parabola. So this is x squared, so one parabola. This is a cubic one, and it's not called a parabola anymore, but you notice how I have two. One parabola here, and they're joined seamlessly. All right, so two parabolas for an x cubed. This is an x to the fourth. You see how we have three, right? One parabola here, one parabola here, one parabola here. Okay, so we have one less parabola than the degree of our exponent. Okay, so a normal positive x to the fourth graph looks like this. All right, but we have a negative. So we are going to flip this. So our graph is going to look something roughly like this. All right, and I'm saying roughly, this is not exactly perfect. There are definite degrees of what this thing could look like and whether it's really exaggerated like this one or whether it's more flattened, okay? Today, I'm not concerned so much with the perfect shape. If you want to see the exact perfect shape, plug it into Desmos. Right now, I just want to make sure that you've got a basic idea of what these look like. All right, so let's list possible zeros here. All right, so remember plus or minus P over Q. Once again, I'm trying to write a G. All right, so our P's, remember, are all the factors of 12, all of our constants. So we know that the factors of 12 are, let's see here, 1 goes into it, 2 goes into it, 3 goes into it, 4 goes into it, 5 does not, 6 does, 7 does not, 8 does not, 9 does not, 10 does not, but 12 does. All right. Factors of 2. Well, that's easy, just 1 and 2, right? So our factors, our possible zeros are going to be 1 divided by 1. Remember, plus or minus on all of these. 2 divided by 1, 3 divided by 1. Okay, so all of these, right? Divided by 1. And then I need to divide all of those by 2 because that's our other factor of our Q. So then we're going to have 1 divided by 2 is 1/2. 2 divided by 2 is 1. I've already got that. 3 divided by 2, I do not have that. It's 3/2. 4 divided by 2 is 2, so I've already got that. 6 divided by 2 is 3. I've already got that. 12 divided by 2 is 6. I already have that. So that's it. All right, then I need to list possible zeros. What could go into this? All right, let's start it out. I generally like to start right here. And remember, all of these are plus or minus. All right, I don't have enough space to squeeze a plus and minus in here, but remember, every single factor is a possible plus or minus. So let's start with 1, and let's see if 1 works. So -2, -1, 26, 37, and 12. Just check for placeholder zeros if we need them. X to the 4th, x cubed, x squared, x constant. We're good. Okay, bring down the -2. 1 times -2 is -2. -2 plus -1 plus -2 is -3. -3 times 1 is -3. 26 plus -3 is going to be a positive 23. 23 plus 1, times 1 is 23. So 37 plus 23 is 7, 8, 9, 10. That is 60. And 1 times 60 is 60. Okay, that's not going to work, right? Because that gives me 72, and that is not 0. Okay, that one don't work. All right, let's try -1. So -2, -1, 26, 37, and 12. Bring down my -2. -2 times -1 is a positive 2. -2 plus 2 is 1. 1 times -1 is a -1. 26 plus -1 is 25. 25 times -1 is -25. 37 plus -25 gives me 12. 12 times -1 is -12. Hey, there we go. 12 minus 12 is 0. Yay. Okay, so one of our zeros is -1. Let's write that down. All right, let's fill in our spaces here. That's our remainder, so that's our constant, so that's our x. And this is a positive. This is our x squared, and that's an x cubed. Okay, I cannot directly factor one that's an x cubed, remember? So we're going to have to do one more step. All right, and we're going to do just a shortcut, and I'm going to tell you that a next factor is going to be 4. All right, so let's bring down the 2. So -2 times 4 is -8. 1 plus -8 is -7. -7 times 4 is -28. 25 minus 28 is -3. -3 times 4 is -12. And 12 plus -12 is a 0. Yay! Okay, that's our remainder. So this is our constant. That makes this our x. That makes this our x squared. All right. So another 0 is 4. And I cannot directly factor this because of the -2 in front. But we can use the AC method, or we can do our division factoring again. And in fact, if I divide this by -3, I could get something, or we could just use the AC method. Regardless, once we do all of our factoring, we're going to end up with our other two zeros are 4 and -1/2. -3. Okay, so -1, 4, -3, -1/2 is usually helpful if we put these in numerical order, but let's just graph them as they are. So x equals -1, x equals 4, x equals -3, x equals -1/2. All right, remember earlier we talked about what the shape is going to look like? It's something like this. We're going to go up here, down in between these two, and up there. Okay, so that's our basic shape. Last one, and it's back to another cubic one. We're x cubed here. All right, so let's list our possible zeros. So all the factors of 6 are 1, 2, 3, and 6. Our q here is 1, so we're plus or minus p over q. Here, q, there we go. Plus or minus p over q. These are all divided by 1, so they're just going to be themselves. So it's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All right, and then let's just divide. So set it up. We're going to start with 1 coefficient is 1, this is -2, this is -5, this is 6. Double check the placeholder zeros. So I've got an x cubed term, x squared, x, and a constant. I'm good. I don't need any zeros. Bring down my 1. 1 times 1 is 2. No, 1 times 1 is not 2. 1 times 1 is 1. -2 plus 1 is -1. -1 times 1 is -1. -5 minus 1 is -6. -6 times 1 is -6. 6 plus -6 is 0. All right. Let's set this guy up. This is our remainder. That's our constant. That's our x. That's our x squared. I have a leading coefficient of 1, so I can do my direct factoring method. So this is x. This is x. Two numbers that multiply to make 6, but add to make -1. And this is a -6, so I know it's going to be a positive and a negative, positive and a negative. So two numbers that multiply to make 6 that have a difference of 1 between them. Oh, hey, 2 and 3, right? I want the bigger one to be negative because the middle term has to be negative. Then I set each of these equal to 0. So x equals -2 and x equals 3. Now we list my zeros. So 1, -2, and 3. Then we graph it. So x equals 1, x equals -2, x equals 3. This is a cubic graph. Remember the cubic graphs we said look like this when they're right side up. Our right side one opened up. And they would look like that when it's negative. So the right side one opens down. We have a positive one, so it's going to look roughly like this. We're going to go up, down, and back up. All right. I know that was a lot. I'm confident that you all can do it. If you need to, watch the video again. And I fully endorse the use of Desmos for this to help you really get an idea of what these graphs look like. As always, if you have any questions, shoot me an email, and I am more than happy to help. Have a great day.